ASME Section 9, Welding Engineering. In this submodule, we'll talk about welding procedure or WPS. In this module, you shall learn about welding procedure specification, WPS, welding procedure qualification record, PQR, and reviewing a WPS against the supporting PQR. WPS or welding procedure is designed by welding engineer to produce a joint with the required strength. It is a written document that guides the welder to produce a sound weld. Sometimes WPS can be simplified into a welding instruction so that only that information regarding the welding parameters is given to the welder on the need-to-know basis. For example, welders do not need to know about the PQR, whereas the inspector needs the PQR should be available to the inspector. You check it against the WPS, see that it qualifies the WPS. The ranges are the same, the parameters or essential variables. WPS shall be written as per the code, and although there are several codes and standards that one can write a welding procedure specification, API adopted ASME Section 9 code as the reference for WPS, PQR, and WPQ, Welder Performance Qualification. PQR, or Procedure Qualification Record, is the supporting qualification that includes the actual values of essential and non-essential variables used at the time of welding, the coupon, the test coupon, as well as the required test, tension, Sharpie, that is performed on the weld and that was produced as per initially as a preliminary WPS or PWPS. So first the welding engineer prepare a welding procedure specification. As long as it is not qualified, they call it normally PWPS or preliminary. So once it's qualified by a PQR, that means a test coupon has been welded and with those parameters that mentioned in WPS and has been tested, say a tension test, and if there is a supplementary essential variables or heat input is an essential variable, then a Sharpie test also is done, and then once it's qualified, you can see the required strength is demonstrated by PQR, so then it becomes a WPS. PQR validates the weld design or WPS. Please note that the PQR demonstrates the soundness of the weld design, whereas the Welder Performance Qualification, WPQ, demonstrates welder's skill to produce a sound weld. So the purpose of them are different. The PQR validates WPS, welding procedure, whereas the WPQ validates the welder's skill and qualifies the welder. It doesn't qualify the welder's skill. So that's why the essential variables are different between them and the testing is done differently. For example, a PQR, a tensile test is necessary, whereas a WPQ, you can always, a bend test is done only, and you can replace it with a radiographic test of the joint. Remember that WPS need to have all the essential and non-essential parameters, but PQR only needs to have the essential parameters noted, the actual essential parameters done at the time of the testing, welding the test coupon. And if the non-essential parameters also are noted during the welding, then it can also be mentioned in the PQR, but it's not necessary to have the non-essential parameters in PQR, whereas WPS need to have the essential parameters. So if you change the essential parameters, you need a brand new PQR, but If you change non-essential parameters, you don't need a brand new PQR, but anyway, the WPS need to be revised with the same PQR when non-essential parameters are changed. Welding position is an essential variable for WPQ, whereas it is non-essential for WPS, because WPQ is about the welder skill. So welder might be able to produce a good weld at one particular position, but not in other position. It should be demonstrated. So that's why the welding position is an essential parameter for variable for WPQ. Welding procedure specification. WPS contains essential and non-essential variables. A variable means a range where a particular parameter can be set within that range. As a general rule, the more liberal the range, the better the weldability, because poor weldability means more restriction, while good weldability means less restriction. Essential variables are those parameters that by changing them, the joint mechanical properties are affected, and therefore you cannot revise the WPS without requalification. This means you need a brand new PQR to the test all over again. Changing non-essential variable does not change the mechanical properties of the weld joint, and therefore requalification of WPS by performing a new PQR is not required. Simply revise the WPS with the same supporting PQR. So here you note that even if it does not change the PQR, the non-essential variables, and you can use the same PQR, but still you need to revise the WPS if you have changed the non-essential variables. You can revise a WPS, but not a PQR. You may revise a WPS by changing its non-essential variables without the need for requalification. However, you're not allowed to revise the PQR because it contains test reports with the actual values of essential and non-essential parameters at the time of building the coupon. Only minor typo correction is allowed. When Sharpie test is also required for qualification of WPS, then supplementary essential parameters, toughness, also applies. In this case, the heat input during the welding affect the mechanical properties of the joint, and often a preheat with restricted heat input during the welding or a post-weld heat treatment after the welding is required. WPS shall refer to supporting PQR and shall be signed by the organization or manufacturer taking responsibility for complying with the code or project specification. So it should be signed by the manufacturer. Typical WPS gives such information as type and size of base metal, type and size of filler consumables, electrodes, drawing of the joint, welding process, range of allowable amperage and voltage, welding speed, welding technique, any preheat or post-weld heat treatment, and the like. WPS and PQR sample templates available at ASME Section 9, forms from pages 308 to 333. Procedure qualification record. PQR lists the actual essential and non-essential parameters used during welding the coupon plus the mechanical test result as required by the ASME Section 9. The mechanical test is mostly limited to tensile test, but may include Sharpie test when toughness is a requirement. And the signs are if there is any preheat or post-weld heat treatment, especially as a supplementary essential variable. So when there is a post-weld heat treatment required, that means the toughness is the essential parameter, supplementary essential parameter, and you need to do a Sharpie test. And the test coupon also need to be post-weld heat treated, same as the production joint. For tensile test, minimum 2 samples tested, and the average shall be equal or above the required minimum tensile strength with no single tensile test result below 95%. And normally they say the breakage should be out of the welding zone on the base metal. Preparing and testing of test coupons can be subcontracted, but shall be under the supervision of the organization, the manufacturer, who takes full responsibility for it. For example, the manufacturer, if it is a pressure vessel, the one who is authorized by ASME to affix the U stamp, that would be the manufacturer. PQR validates joint design and approves WPS. PQR cannot be revised, and PQR should be available for inspector's review, but need not be available to the welder. Now, how to review a WPS against the PQR to see that that PQR actually qualifies the WPS? The focal point and signatory for approval of WPS is the organization or the entity manufacturer who is authorized by ASME to stamp the equipment as per code. The inspector should be able to check the WPS against the PQR and ensure they are compatible. That is, a PQR can validate the WPS in terms of essential parameters as per ASME Section 9 code. An example is brought in Appendix C of API 577. The review sequence is 1. Check the WPS against the applicable table of ASME Section 9, QW252, to ensure that all essential, supplementary essential, and non-essential variables are noted. Check the PQR against the applicable process in ASME table section, ASME section 9, to ensure that all essential, non-essential, and supplementary essential variables, if any, and all the required mechanical tests completed. And this is QW 200.2b. PQR should be certified as accurate by the owner organization and cannot be subcontracted. PQR cannot be revised or changed except for additional corrections. All changes need recertification by the organization. Check the sample weld coupon dimension, thickness, diameter to ensure it covers the range noted within the WPS. For this, you need to see QW451. So this is the most important table for the API exams, and see that the type of joints, pipe, plate, and the thickness, especially under the diameter, is actually qualifying and the type of, like a butt weld or groove weld, actually qualifying the WPS. So we brought part of this QW451.1. As you can see here, it doesn't show because we have a Copyright Act problem, so we just show part of it. So for different thicknesses, it's from the thickness or half of the thickness up to 2T. So say if you weld the test coupon 10 millimeter, then it is valid from 5 millimeter to 20 millimeter. And this one shows the number of tests you have to do. So you have to do 2 tension tests for up to 1.5 millimeter, 2. It's all 2 tension tests. And as the thickness increases, you need to do other tests like side bend test. Now this side bend test can be, there are notes that says that can be replaced by a radiography. So most of the WPSs are PQRs are test as done with a tension test. If there is a supplementary essential, then a Sharpie test, but normally it's a tension test with either a side bend test or a radiography. The same way about the WPQ, welder performance qualification, the side or face bend test can be replaced with a radiography. There shall be a few questions about reviewing WPS and PQR involving only one welding process, most probably shielded metal arc welding, single V groove weld with the same P number. For range of P number qualified versus P number tested, you need to go to QW422. No, if you don't know where to find this table within ASME 9, go to list of tables. Remember page 183 or table QW51. Some facts from ASME 9. ASME section 9 is divided into three parts: QW welding, QB bracing, and QF fusing. You only need to look at QW welding. Although some of the tables for QB and is merged with QW. For example, QW QB 422. Now, according to QW 409, heat input is equal to 60 times into amperage into voltage divided by travel speed in inch per minute. The 60 is come from a minute because they do the seconds, so they at the 60. And the unit of measurement is joules per inch. For fillet, well, WPS, parent material thickness, is not an essential parameter, so that is no limitation on thickness. So this means if you qualify a joint, a butt weld joint, it can qualify the fillet weld as well. Want to make a fillet weld there as well. PQR should be available to inspector for review, but need not be available to the welder. 2 or more WPS may be prepared from a single PQR as long as the PQR covers these ranges. Similarly, 1 WPS can be used for 2 or more PQRs combining the qualification ranges. When a group of material have similar composition, weldability characteristic, mechanical properties, they are grouped together with a dedicated P number. So P number means that a group of material that have the same composition, weldability characteristic, and mechanical properties. This is done to reduce the number of WPSs because material from the same P number can use a unique WPS. So if you change the material, as long as it is within the same P number, you can use the WPS from the other material for this material. There are some exceptions. For example, if toughness is a requirement, then the material would be further subclassed within a P number called group number. So material with toughness requirement shall not only be from the same P number, but also same group number in order for them to use the same WPS. The manufacturer organization is responsible for preparing, documenting, and certifying the WPS and supporting PQR. For qualification range of thickness for groove weld, you need to refer to QW 451. For qualification range of diameter is 452.3. List of essential, non-essential variables in table QW 253, and list of essential for other processes such as SAW, gas metal arc welding, submesh arc welding, gas tungsten arc welding, and PAW are brought in various tables, as you can see here. And also electro slide welding, ESW, is this table, 258. The intention of welder performance qualification is to prove the ability of welder to weld a joint as per approved WPS in a particular welding position and welding process. This is coming from QW 301. So it is in a particular position and he is qualified in only that position. Obviously, some position can cover 2 or more position or all positions. All welders for manual welding and welding operators for automatic welders shall be assigned a number or symbol in order to document which welder welded a particular joint. So this is about identification of welders. Welder performance qualification thickness limit and the required test specimen are brought in QW 452. So 451 and 452 are actually those tables. These are the most important one during the exam. And 461.1 shows position of welds for groove welds. 61.2 shows for fillet welds. And as you can see here, there are various tables that we referred here. Most probably you won't need these tables, but just for your familiarity, we have brought this and you can refer to them. Remember, most of what you need to know from ASME section 9 is between page 170 to 190. So this is a good hint to remember that if you cannot find a table or in the open book, look at the list of tables. If you cannot find it there, go to list of table of contents. If you cannot find it there, you go to list of tables or figures, because they are shorter, it's quicker to peruse. Even if you cannot find them, then remember that go to page 170 and peruse up to 190. Most probably you will find the information you need to solve the question in the exam. Content of WPS. ASME 9 has provided templates for WPS in the form section as a guideline. It specifies essential, non-essential, and supplementary essential as a must-have in the WPS. To find out which form to use for a particular welding process, you have to go to ASME section 9, pages 308 to 333. You most probably don't need it, but it's just as for your information. API has listed items typically noted in the WPS in section 642. As a general rule, you should expect the following in a typical WPS according to API 577. And as you can see, WPS number, revision number, supporting PQR number should be mentioned. This is might be an exam question. Logo of the company and should be signed and dated, and type of welding process. Parent material P number and group number, joint drawing, sequence of process electrode, qualified range of thickness and diameter, any preheat, post-weld, any welding speed and technique, shielding gas type and flow rate, voltage and amperage range. Remember that welding position is a non-essential parameter for WPS. I mean, this is not absolutely true, but in most cases that's the case. And for your information, you can rely on this statement. Content of PQR, ASME section 9 has provided the following guideline. It specifies actual, essential, non-essential, and supplementary essential, plus the mechanical test results as a must-have in the PQR. Now, non-essential is not necessary unless it's recorded, because it should be the actual non-essential parameters. Look up the list in the section forms, again from 308 to 333, to see how a PQR is actually, the templates are there. API 577 has listed items typically noted within the WPS in section 643. As a general rule, you should expect the following in a typical PQR. PQR number, logo of company, signed and dated, and type of welding process, P number of the test coupon, joint drawing, sequence of process, actual thickness and diameter of test coupon, actual weld deposited, actual voltage and amperage used, a polarity, any preheat, interpass, post-weld heat treatment applied, actual welding speed and technique, shielding gas type and flow rate, number and size of tensile test and bend test and the results, welder name, inspector's name, supervise the test. You can see that there is no mention of WPS because the WPS refers to PQR, but it's not the other way around, because the same PQR can be used for other WPSs. So it's not specifically assigned a number and cross-reference to WPS. Whereas the WPS should be always cross-reference to PQR because PQR validates that. Other qualification tests that normally done is a visual test, liquid penetrant to detect cracks open to the surface, macro examination. So macro is anything that you do with you visually test with your naked eye, and normally you can use a magnifying glass, but it should be around 5 times, 5x. Anyway, it should be less than 10x in any case. Otherwise, it's not macro, then it will be micro examination above 10x enlargement. Sharpie test to determine minimum toughness at certain temperatures, and normally that temperature is minimum design temperature. Hardness test and chemical composition test. Tube to tube sheet welding procedure. You need a minimum of 10 mock-up welds to qualify each tube to tube sheet welding procedure. So for PQR, you need 10 mock-up welds. And qualification tests include visual examination and just a PT test, and sectioning for macro examination to see that the weld is joined across through the thickness is sound and there is no defect there. W288.1 lists essential variables for procedure qualification of tube to tube sheet welding, which is P number, A number, which is the weldment, and F number is for feeder metal group, and thickness, joint design, welding position, amperage, voltage, polarity, preheat, post-valley treatment. You need a minimum of 5 mock-up tests to qualify a welder. This is the tube-to-tube sheet picture that you will find in the heat exchangers. Thank you for listening. See you next model.